Hi, we're going to talk a little bit about waves, and I want to give you some slides. I want to give you some calculations, and most of all, though, I want you to see that waves are really cool. They're an amazing way that energy moves through a medium with a cyclical displacement, or there's a way that waves have this pattern that we can see. So I want you to think about where waves show up and some of the places that you're familiar with waves. And then I want us to get into a little bit of how we name and label and study those patterns and where those patterns turn out to be really important. You probably think, first of all, when we say waves, about water waves, about waves at the ocean or waves on the beach. And that's a great place to start thinking about waves. But of course, other really important examples of waves are the sound that you're hearing right now. So all the sound that we hear, all the sound we process, that travels in the form of waves, and we'll look at sound waves. And of course, light also travels in the form of waves. And the different colors of light that we perceive or see are different aspects of light waves. So we'll talk about those things. We already saw a little bit of electromagnetic radiation with infrared heat, and infrared radiation also travels in waves. So we'll look at waves a little bit. I want to show you a slide set. So we'll start here, and I just want to talk for a minute about waves and some of the wave properties and wave characteristics, and then you'll have a chance to answer some questions about waves after video. So this is just a droplet of water that's landing into a still surface of water. And what you can see is that it creates those ripples that move outward from the center. And what those ripples represent is waves. They're circular waves emanating out from the midpoint. So what's interesting about water waves is that if you think about a water wave, you think the wave is moving, and it is. The wave is a moving displacement or moving energy, but what's not moving with the wave is all the water. The water is simply going up and down. So you know that water waves are where the water goes up and down, and we'll think about that when we look at the medium and the way that a wave moves through a medium or moves over the surface of the medium. So I'm going to look for a minute at a wave the way we draw it and some important names for the parts of the wave. So here you can see a wave that's drawn. And the most important characteristic of the wave that we're going to talk about is probably the wavelength. Wavelength is exactly what it sounds like. You can see the wavelength is indicated here. And the wavelength is actually the size of a wave. When I say the size of a wave, I don't mean how tall it is. That's got its own name, and that's called the amplitude. So the height of a wave, how high it is from this baseline, or the zero energy baseline, up to the top of a peak, that's called the amplitude. That's kind of the strength of the displacement or the height of the wave. The amplitude is always measured from the baseline up to a peak, or from the baseline down to the bottom of a valley, or what we call a trough. So when we think of a big wave, we often think about surfing a big wave. We think about how tall it is. But wavelength is not how tall it is. Wavelength is actually a measurement of this pattern of a cyclical repeat of a wave that goes up and down and up and down and up and down. When we get that pattern, we're going to actually have a series of peaks and a series of troughs. And so if we measure the distance from one peak to the distance to the next peak, if we measure that in meters or centimeters, that's going to give us a wavelength. And the way that we talk about wavelengths and equations is with a Greek letter that maybe you're familiar with or maybe you haven't seen before. It's called lambda. So that Greek letter lambda, it looks like a letter Y that's upside down and backwards, but that's a lambda. That means wavelength. And you can see exactly what a wavelength is here. So let's go on a little further. Here, we can actually relate some things together and talk about the wavelength and the frequency. Now, in these pictures, our waves are actually static. So it's a little bit misleading because it looks like the wave is just sitting there. But a wave isn't just sitting there, a wave is moving. So we can imagine this wave moving to the right. And if we did that, we would actually be able to count how many times a crest passed us. We'll see this in just a minute with an animation. But I just want you to get this vocabulary first, and then we can apply this vocabulary when we look at in a moving wave with an animation. So if wavelength is lambda, the distance from peak to peak, then what's this idea of frequency? Well, frequency is exactly what it sounds like. It's how often something happens. So if I was going to tap the table, and I'll actually tap my kombucha bottle. That tapping has a frequency. 1, 1, 1, 1, 1, 1, 1. And frequency is how many times per second. So let me tap with a frequency of 2 per second. Now with 3 per second. Now with 4 per second. So frequency is how many times something happens per second. And we could talk about the frequency of anything. It doesn't just have to be a wave frequency. It could be the frequency of tapping a kombucha bottle with a spoon. It could be the frequency of clapping your hands, of blinking your eyes. But when we talk about the frequency of a wave, we're talking specifically about how many wave cycles or up and down cycles it completes in a second. How many a second? So 1, 2, 3. The up and down from start to finish is one wave cycle. So if we say wave cycle, it's when the wave starts here, we go up to the top, down to the bottom, and come back up. That's a wave cycle. So how many times does it do that per second? Well, if it did that 3 times a second, it would have a frequency of 3 per second. And we're going to call that 3 hertz. So wave terms and units. Here's some important vocabulary. Wavelength, measured as a distance, has the variable lambda. There it is in blue. Lambda, the distance between wave peaks. It's in meters. It could be in feet. It could be in inches. It could be in miles. It could be in centimeters. But in our standard metric unit of distance, meters, we'll see it meters, or we'll see it with a prefix like kilometers or nanometers or centimeters. Frequency in an equation is also going to have a Greek letter, and it's the Greek letter nu, N-U. So I like to compare it to the other nu, which is a wildebeest, but I'll do that later and make a little cartoon for you. Here is the Greek letter nu. It looks a lot like a curvy V. It's not the letter V. It's not the letter U. It's the Greek letter nu, and it means frequency in wave cycles per second. 1 wave cycle per second we call 1 hertz. So hertz are the measure of frequency, and 1 per second is 1 hertz. Period is actually another way of thinking about a wave cycle in time, but instead of saying how many wave cycles per second, we say how many seconds per wave cycle. So it's just the inverse of frequency. If I'm tapping 3 times a second, 3 times a second means every tap takes 1/3 of a second. So period turns out to be the inverse of frequency. And then finally, what about the speed of a wave? Well, if we know the frequency of a wave and we know the wavelength of a wave, then the speed of the wave is wavelength times frequency. So we're going to say V equals lambda nu. That's the way we're going to say this equation, or the speed of a wave is the wavelength times the frequency. And we'll make some calculations with that. If speed is wavelength times frequency, then it must also be true that you can find frequency as V over lambda, speed over wavelength, and you can find lambda as V over nu. So those are some important terms. That's a first presentation of that. We're going to do a separate video where we're going to take a look at an animation, and we'll walk through it and see how the animation lets you apply these things. But I want you to start by getting that vocabulary so that you know what those units are for each of those terms, and you have the vocabulary for the parts of a wave. That's all for this.